look at confidence intervals for one proportion. Before I do, let's do a little bit of notation. P will indicate our population proportion, and then P hat is going to represent the sample proportion. For confidence intervals, my formula is P hat minus Z star times the square root of P hat times 1 minus P hat over N is less than P hat plus Z star times the square root of P hat times 1 minus P hat over N. And this Z star times this square root, that's the same on the right and the left, this is my margin of error. For Z star, if we're doing a 90% confidence interval, we'll use 1.645, 95% will be 1.96, and 99% will be 2.58. Let's suppose we had a survey of 250 adults that revealed that 155 of them drink coffee in the mornings. And I want to give a 90% confidence interval for the true proportion of adults that drink coffee in the mornings. The first thing I'm going to do is look at my variables, P hat, Z star, N, and I'm also going to go ahead and look at 1 minus P hat. For P hat, we have 155 out of 250, so we just need to divide these two numbers. This gives us a value of 0.62. We can then use that to find 1 minus P hat. That gives us 0.38. N, this is the total number of people in the survey, in this case, 250. And then finally, Z star. Since we are doing a 90% confidence interval, we will use 1.645. Now that we have this information, let's look at our margin of error. As a reminder, this was given by Z star times the square root of P hat Q hat over N. Plugging in our information and then computing this gives us 0.05 as our margin of error. Our final step, we want to both add and subtract this margin of error from P hat minus 0.05 and P hat plus 0.05. Using our value of 0.62 for P hat, we get 0.57 and 0.67. So the true proportion will be somewhere between 57% and 67%.